Okay, so I saw these things online everywhere, and I saw a little review lately of somebody that was using that for a different purpose than what I had in mind. And they seem to be everywhere. If you look on the over here on AliExpress, there are several other sellers here that come at different prices, 308, 227, and there's literally many more. There's also one that's being sold for $202, so I'm not sure which sellers are reliable or not, but I didn't see that 202 one. I ended up buying from this particular seller, but I'm not going to recommend any of them. If you look at Amazon, they also sell these things, and there's literally dozens of them. They cost more on Amazon, but not necessarily. But you have to be careful. You see $85 delivery, $70 delivery, $100 delivery, this kind of stupid stuff. So they're definitely more expensive. I saved at least $100 or more buying it on AliExpress, but as you can see, they are literally everywhere. This keeps going. So somebody in China is making these things, and sellers are actually reselling them. So let's have a look at it. Now, what I had in mind is to use this thing for electronics use. Like, quite often I come across situations where I wish I could solder a wire or a resistor or whatever component to stainless steel or aluminium or aluminum if you come from the other side of the pond. And there are some fluxes and supposedly solders, but they are not very successful at all, especially not aluminium, because it absorbs the heat so much you need a very large soldering iron to even attempt that. So I thought one of these things might even be useful for that. So what this actually is a small TIG pulse welder. It is not suitable for welding, complete welds, but it does spot welds. And I do have a spot welder that I use for doing those strips, that you would weld onto lithium-ion cells and so on. But it's not suitable to do anything else than that. And that particular device lives over here. This is it over here. And it does a good job on just on the strips onto the cells and so on. But even sometimes if you want to solder or spot weld onto like a bus bar or something like that, that's heavy metal, maybe even a different metal, then that won't work either. So that's why I thought maybe this machine here would be suitable. So anyway, what you will see over here is, let me turn it on, it has different settings. This is AUs for gold, cobalt, chromium, a hybrid, not sure what hybrid is, but I guess undetermined alloys, titanium, and auto. Suppose something to do with probably the little wires that people use for false teeth or something to keep them in place. I think that's what it refers to. And now it comes with a bunch of, let me adjust the camera here so that you can, so it comes with a pressure gauge here and a hose in case you want to use it with argon. And indeed, in some instances that would be desirable, because you will see there is quite a bit of, potentially, depending on what kind of metal you're using, there is some potential there for getting oxides and so on, and black smudges, but so far what I've experimented with, I found that some isopropyl alcohol actually cleans it up pretty well, and I don't think I particularly need to use argon. Comes with a little grinder over here that you use in order to there's a needle, a titanium needle in there. You can grind a point on it, and after some little bit of use, that point will kind of disappear. So you need to sharpen it again with this. They say 25-degree angle, but I found that it is not that critical. And it came with a bunch of needles, extra needles, and some little holders like you'd find to hold the needles in place. And then it has a stand, as you can see here, and you can actually bring a something up to here and actually hold it, and it'll zap it, or you can actually take it out and use it by hand. And if you look carefully, let's zoom in a bit again. If you look carefully there, this opens up, and this is where the titanium needle fits. And as you can see, it actually compresses here. There is a solenoid in there, and what actually happens is that when you connect it, when you just barely touch it to whatever you're trying to use, and then there is a time over here that it allows the arc to exist, and then at the end of that time it pulls the needle in automatically. And that's important, because if it stays connected to the project, you'll end up welding the needle, the titanium needle, to the whatever you're welding as well, so that's undesirable. So as I said, it comes with different settings here. This is supposed to be for gold. It has a power, and it says percentage, but I gather that the minimum power is 1 and the maximum power is 10. So this would be 100%, 90%, 80%, 70, 60, 50, 40, 30, 20, and 10. And there's time in milliseconds, and the maximum seems to be 30 milliseconds, and the minimum I think is 2 or 3, actually 3 milliseconds. And these settings over here, they are presets, and you can see there's a 60% power, 18 milliseconds for cobalt chromium hybrid, 521, titanium 615, and this one, as I said, I think it's for those little stainless steel wires that you find in false teeth that are partials, probably because it says orthodontics in the manual, is 2 and 6. Over here is a control that actually controls how much argon will flow. Since we don't have argon, we can ignore that. It works fine without argon, but you will get some oxides and some smudges that you'll have to get rid of. Now, comes with a little manual, and I've noticed that some of the others seem to have different manuals. Maybe they're better. This one here is a dual English and Chinese manual, and as usual, it is very poorly translated and not that much use because of that. And it's interesting, they got a picture here where they actually show a microscope being used with the device. It seems to be, it has a different stand than a microscope and so on. There must have been a different model at some stage. No one seems to sell these that had a microscope with it, but they're using the same manuals as microscope parts should be self-prepared by users. And I think what they're trying to say is that the microscope is not included. Anyway, I see very little here, just shows you what's included with the device and so on. So as you can see here, that the orthodontics ticks, whatever that means. Adjust deflate time second. They're talking about argon. Pure titanium mixed. It says that that hybrid one. It says mixed. CR, chromium, cobalt alloy, and gold. And anyway, not much. It's pretty simple to use actually, but gives you an indication of what's in the wand over here. The needle should be sticking out 10 to 15 millimeters. I've been experimenting a little bit with it, and what I have deduced so far, and I still got to do some more experimenting, and I'll show you what I've done so far, and we'll do a few test welds as well, is that this thing actually produces a strong arc with the titanium needle, and it actually melts the metal very quickly and very short time, you know, from 2 or 3 to 30 milliseconds. And the power, according to what the manual says, where's the page with you? And I don't know how accurate that is, but it says over here, I don't know if you can, probably hard to read, but I'll tell you what it says. It says here that it uses welding voltage of 40 volts, and the welding current is 50 amps to 600 amps. It uses 100 watts of power when it is running, and there's not much else to mention here that we are interested in. So what I have found is that if you set this to very low power and increase the time, almost, and if you actually use the nut, it comes with two different titanium needle sizes, 0.6 millimeters and 1 millimeter. I got the 1 millimeter one mounted, and so far everything I've done is with the 1 millimeter one. I guess if you got really fine work, and they say that it's been designed for jewelry, so I can imagine that you could have very fine pieces of jewelry. You might use the smaller needles, but I think the 1 millimeter needle is good. So if you use quite low power and a longer time, it almost works like a spot welder. It sends current to the pieces that you're trying to weld together, and there's not much of an arc, but it does get hot enough. And if the two metals are the same, like if you're dealing with copper to copper or steel to steel or whatever it is, and it is, you know, they are of a fine consistency, you can actually get away with that. But usually what happens is you will use a higher power, maybe 4 or 5 or something like that, and a much shorter time, and it actually creates a very bright spark, and you really need to get some fast acting welding goggles. I have some welding masks like that, but that's for arc welding, but that's too big. I have these ultraviolet glasses over here because it produces a very strong ultraviolet arc and not very healthy for your eyes to look at. Now there's a bit of a delay. You can hear a click on the machine, and then it actually connects and the arc comes. So you can, if you are quick enough, you can close your eyes while the arc is, and then open them again afterwards. But these glasses actually, they don't reduce the brightness that much, but they do filter out the ultraviolet, and it is, you can feel it. It doesn't seem to hurt your eyes. It's a bit bright, but they do work. But it's not obviously perfect. Anyway, So that's one thing that I think if you're going to use this thing often that you've got to be aware of, you might want to get. So it came with a ground wire, which is this one here. It's got two terminals over here for grounding, and it's just an ordinary banana plug and a crocodile clip. I've actually plugged in a second lead with a crocodile clip, which I happen to have in my supply for power, because I will show you what I have found so far that I think is worth noting. Like for instance, if you want to weld, I actually took these two paper clips here and I welded those together, and I could hold them in a holder like this, and then I find it good to connect ground to both sides like so that both sides of the wire that you're welding is grounded, so that the arc will strike both of them. And in doing so, I was able to like if you only got it on one side, it may not. Well, this is metal; it might also work, but I think it is beneficial to have two. And it comes with one, but you might find that your uses will vary. So, and this made an excellent weld. It's like, it's completely welded together. It did a very good job on that. So I can well see, like some people, I think, on comments, like on Amazon and so on, they're saying, "Oh, I'm using it to repair like metal glasses, the metal frames on glasses," and I can well see that would work. And plus, the one plugs into there. And another thing I found is that if you are wanting to weld pieces of wire, I did another paper clip, a finer one, also a very good weld in those wires there. Then I find that I use this little anvil over here and a little hammer, and I flatten out the wire a little bit. Makes it much easier to touch the wire with the point of the probe. That seemed to be beneficial. Okay, so let's change cameras and we'll have a look at some of the things that I've done already. Now, what I've been doing is, and I still got to do some more experimenting. Let me, as I said, change cameras. So this is so far some experiments that I've done. The settings that the first one is power and the second one is the milliseconds. 618 seem to be working good on sheet metal, which is what I've done here. I've welded together two pieces of sheet metal over here, and they are stuck together nicely. As you can see, it's quite black. I didn't clean that one off. A little bit of a wire brush or something like that would clean that off. But if you had argon, of course, that wouldn't be like that. As a side, I think most people use these little scratch brushes. There's a steel one and a fiberglass one and so on. And these things can be used in order to clean off the welds. And if you use it with, as I said, with a bit of alcohol, it's already much cleaner. You can see there's two welds over there. And it looks like on Amazon, at least, a lot of people are buying these things with the machine, so they must know about that as well. And that large paper clip over here, I welded together with 512. I welded a piece of wire to some sheet metal over here, and this is stuck quite nicely, and I've used a multimeter on all of those to make sure that they made a good connection, and indeed they are all perfectly shorted to the metal, and it's quite strong. So that one is I used 6 milliseconds, 50%, 6 milliseconds. And then the solid copper to the PCB, that's another little experiment that I did. And an old piece of PCB here. Now there was some copper exposed there, and as I said, there's some black on there because I haven't cleaned that one off either, but it made a very good connection to the PCB. So that seems to indicate that if you've got some of this nickel strip, you could easily connect, spot weld that to a PCB. And in fact, some of the PCBs that come from China, little lithium-ion battery boards, they already have a piece of metal soldered there to make that even better. But in any case, this works fine on copper. And as I said, when you're using the two similar metals, it's much easier because the metal has to melt temporarily for a few milliseconds to join together. And if they both got the same melting point, that is obviously a lot easier. Because I did some experiments here on stainless steel. I didn't write down what I used for that. That was an early. This is actually a nickel strip. This is stainless steel, nickel strip, and this is copper wire. And if you look carefully, you will see that the actual wire melted, but the stainless steel, has a much higher melting point. The surface of it must have melted a little bit because it is well and truly stuck, but it does make it harder. You got to get the settings just right, otherwise the copper might evaporate and it won't, it'll just the wire won't be connected then. And if you look carefully at the nickel strip here too, I could have used a bit less power because there is some welds there, but there are also, it made holes in it, but nevertheless it's stuck well and good, and it's a good electrical connection as well. You can probably see that on the microscope. You can see what I mean here. Turn down the light a little bit. You see the nickel strip? It actually made holes, but those two little beads over there are actually melted into the stainless steel, so it did make a good contact. And it's the same with the copper wire. And as I said, I'm still experimenting. I think that a little bit less power for a longer period probably would have done a better job, but I'm not, as I said, I'm not finished. I got to do some more experimenting and write down what I am doing with that. And another thing that I did was where is it? This one here is actually same thing, but it's actually welded to aluminium, nickel to aluminium, and it is obviously that little bead over here that's making a good connection, but the other two there are just melted, but it does work. I was able to with the right amount of power and stuff, you can spot weld nickel strips to aluminium as well, and wires for that matter. And here I've got some thicker sheet metal I should say, and it's the same deal. Nickel strip, there's a hole in there because I used too much power when I was experimenting. And again, this wire over here is melted into the steel, and you can see over here I had another try and the bead wasn't big enough, and it's actually stuck on the metal. That's copper that's melted into the. Now this steel has some sort of probably a zinc coating or something on it. It's rust proof. And now let me have a look where my other. This is some very thin sheet metal. Comes off like this little cage where some electronics was underneath. Let me see now, where's the. This is you see how I flattened that out with a little hammer, made it easier. This is one of those metal film resistors that have very fine wires on them, and yeah, it's made a good contact. And over here I got some stranded wire that I did also on this piece of sheet metal. And another thing that I did was I put a spot weld on this little bolt over here. You know, quite often you are working on a project and you wish that you could sort of spot weld a little nut to something so you don't have to hold it while you are screwing a bolt into it, or vice versa. So this little bolt over here is you can see how the weld went. It zapped right into the head of the bolt and then the edge. It's easier to do edges on this thing too, I've noticed. So in any case, it's a really solid connection. And again, I guess this is steel, both of them, so that made it a bit easier as well. So that's what I've done so far. And as I said, I'm still going to do some more experiments so that I have a record of what powers to use. Oh, and another thing that I did was this is a piece of a 9-volt battery over here. It actually has some circuitry inside that was failed, and I actually spot welded a piece of wire to those nickel strips over there, so that works as well. And quite frankly, sometimes you come across a PCB or something like that, and you've got to connect something to the PCB, but it is a very heavy PCB, like a ground plane or something like that, and you need a really heavy duty soldering iron or a lot of heat. I think this thing would be able to do that as well. And of course the heat is strong, but only on a small area. So if there's any plastic components or anything near it, it probably wouldn't affect it. So let's have a look how this thing works. All right, well, for some reason the camera's picking up the flicker of the displays, and it certainly does not look that way when I'm looking at it. So let's adjust this camera over here so that we're not seeing that, and I'll just tell you the settings. The top one is the power and the bottom one is the length of time. Okay, so I've got a piece of this stuff that I don't know what it is called. It is completely heat proof. You find that in heaters and hair dryers and stuff. I happen to have that laying around in my junk box. Don't know where it came from. You could also use a little piece of silicone rubber like this. Now this is silicone rubber as well, but it makes black smudges, and this is totally heat proof, so I'm using that for my little base over here. This is a piece of aluminium or aluminum, depending on where you come from, and quite often I find the need, in order to like some of the battery packs that I've seen, they have aluminium sort of bars in them, and they have stuff soldered to them or welded or whatever they do it. I have had very limited or actually not much success trying to solder to it, even with special fluxes and all sorts of stuff. And quite often this is one of those nickel strips. I would need to connect to it, and so let's have a look what we can do. There's two little lights on there that says wait and ready, so you got to wait until it says ready again. What I suspect is inside of that machine is a a bank of capacitors that charge up, and then some MOSFETs that actually release the power depending on the power setting, through the needle there. Okay, well, this seems to be stuck pretty good here. I think that was relatively successful. Yeah, that's a very good connection. So this shows you the use of this thing, where you can have dissimilar metals connecting to together, which is quite a usually a hard thing to do, but this thing can do it. Oh, this is very solid. And just in case you are wondering, a little bit blurred, but you'll get the message. That's complete connection, 0.1 to 0.2, and that's the resistance of the actual leads. To connect the leads by themselves, I get 0.2, so that's a complete, very good electrical connection, and a very good mechanical connection. I can't pull it off, so that's a success. And here we have a piece of copper wire. It is looks like it's like tin coated or something. Now what I tend to do with these is I flatten it out a little bit like that. I have more surface area. And let's have a look. What do we want to connect this to? Well, I guess again, quite often I need to connect wires to these nickel strips as well. So let's try that. I have already, connected it to sheet metal and stuff like that. It was quite successful. Now this one I'm gonna give it 40% to start with. As I said, I'm still experimenting, so we'll see what that does. So what I have found is this copper actually melts at a much lower temperature than the like steel and so on. If I give it less power, and sometimes for a longer time, then I will actually have more success. But it doesn't look pretty, this one. But it is a very solid connection nevertheless. So that's also an easy way to connect wires to nickel strips. And let's have a look. Here's a little thick piece of sheet metal, and here's one of those pieces of wire that comes off, like when you have little DuPont pins and so on. I wanted to get it through that hole there. Oh, the little lead came off. I'm giving that 50%. That's a good connection. Now 50% at 6 milliseconds. So I can also see myself using this to repair, like sometimes I've got little switches, you know, they got little pieces of metal in there or springs that are broken. All be useful to be able to fix with that. Anyway, that's how it works, and I think this is a good little piece of kit here that I will be using for specialized projects, I mean battery packs and what have you. So that's all I've got for now. And as I said, I did some heavier duty welds on like little bolts and stuff, and that worked just fine too with higher power. You can turn the power right up to 100% in 30 milliseconds, and you can actually weld, spot weld, tech weld, you know, like fairly large nuts and bolts and things in place as well. Anyway, I'll see you guys later. If you liked this kind of video where we investigate stuff, give me a like and subscribe, and I'll see you guys next time.